Let us now do the principle of conservation of linear momentum. What is the principle of conservation of linear momentum? It states that the total linear momentum in an isolated system remains constant in both magnitude and direction. Okay, now what is an isolated system? An isolated system, a system in which the net resultant external forces is what? Is zero. Okay. What are external forces? External forces are forces from outside a system that act on the object in the system. E.g., that will be your applied force, also the frictional force, tensional force in the rope, etc. Okay, so this is supposed to be E, tensional force. Okay, so in symbols, talking about the conservation of linear momentum, in symbols that will be the total momentum initial is equal to the total momentum final. Okay, now we are going to use two cases. One case will be that when objects collide and they separate. Okay, now let's say before the collision we've got object 1 and object 2. Object 1 has got mass 1 and it's moving at velocity initial 1. So this has got what? Has got a momentum. This object also has what? Has a momentum. Okay, this is before the collision. Okay, now after the collision, the two objects move in opposite direction. Okay, so it means this mass had a momentum initial and also has momentum final. This object has momentum initial and this one has momentum final. So what is the conservation of momentum mean? It means the total momentum before the collision. If we add the momentum of ball 1 and ball 2, if we add these two momentum, the momentum of this ball and that ball, before the collision, there must be, the total momentum must be equal to the momentum of ball 1 and ball 2 after the collision, meaning the momentum is conserved. Momentum is conserved. Now, that will be the sum of momentum initial is equal to the sum of momentum final. That will be the momentum of ball 1 initial plus momentum of ball 2 initial is equals to momentum of ball 1 final plus momentum of ball 2 final. What is the formula for momentum? That will be your mass multiplied by velocity 1 initial plus mass 2 of ball 2 velocity 2 initial. This is the total momentum initial, which is equal to total momentum final. That will be your mass 1, this one, velocity of 1 final plus mass of object 2, velocity of 2 final. Okay, now we also have a second case when what? When two objects, a second case when two objects collide and join together and move as a unit. Now we've got mass 1 that is moving in this direction and mass 2 that is moving in the opposite direction. Now they collide. Okay, after the collision they join together and move as a unit. So how do we do the conservation of momentum in this case? We still say the sum of momentum initial is equal to the sum of momentum final. That will be your momentum of object 1 initial plus momentum of object 2 initial is equal to the momentum of these two combined. Okay, so that will be your m1 v1 initial, m2 v2 initial. Okay, that is the momentum of 1 and 2 added together initially, and now that the two objects have joined together, that will be the mass of 1 plus the mass of 2, the mass of 2, and they've got what? They've got a common final, they've got a common velocity. Okay, so hence we say it's Vf. Okay, because they are moving as a unit. They move as a unit. Okay, now let us do example 1. Now with example 1, doing the principle of conservation of linear momentum, a trolley A with a mass of 4 kg moves to the right at 6 meters per second and collides with another trolley B with a mass of 8 kg that is moving to the left. Okay, after the collision, B moves at 3 meters to the right. Calculate the magnitude and direction of trolley A's velocity. Okay, now before we can answer this question, let us start by collecting our data. Now for our data, let us see, we've got what? We've got the mass of A. What is the mass of A? We are told that the mass of A is 4 kg. Okay, we also know what? We also know that it is moving to the right. The velocity of A initial is equals to, now before we collect our data, we need to indicate direction. Okay, let us see, we are taking that direction to the right to be positive, and we are taking to the left to be negative. So because it is moving to the right, that will be positive 6 meters per second. Okay, so what do we all have? They say it collides with trolley B, mass of B, that will be what? That will be 8 kg. That will be 8 kg. That is moving to the left. Okay, so the velocity of B initial is equals to negative 2 meters per second. Okay, because it is taking that direction. Okay, after the collision, we moves at 3 meters per second to the right. Now we have what? We also have VBF. Okay, to the right, so that will be positive 3 meters per second. Now we are asked to calculate the magnitude and direction of what? The magnitude and direction of trolley A's velocity. Okay, so we are looking for VA final. We do not know what is VA final. Okay, the final velocity, VA final. We are looking for that. Okay, good. Now let us come back. We're gonna say the sum of momentum initial is equal to the sum of momentum final. Okay, that will be what? That will be what? MEVAI plus MBVBI is equal to MEVAF plus MBVBF. Okay, and now we come to do what? We come to do the substitutions. That will be what? That will be the mass of A, we're told that is 4 kg. Initial velocity, that will be what? That will be positive 6 plus the mass of B. Mass of B is 8 times what is initial, it's negative 2. Okay, it's moving to the left, is equal to the mass is 4, okay, and then we're looking for what? We're looking for VAF, okay, that will be VAF plus, what is the mass of B? The mass of B is 8, and now final VBF is positive 3. Okay, now we do 4 times 6. 4 times 6, that will be 24 plus minus 16. Okay, 8 times negative 2, that will be negative 16, is equal to a 4 VAF plus 8 times 3, that will be 24. That will be 24. And then what do? We transpose this to the other side. That will be what? That will be when adding the 2, that will be 24 minus 16. That is equal to 8. This will give us 8. Transposing this to the other side, that will be minus that will be minus 24 is equal to 4 VAF. Okay, so 8 minus 24, that will give us minus 16 is equal to 4 VAF. Okay, and then what do we do from here? From here we have to divide both sides by 4. Okay, dividing this by 4, dividing that by 4, this cancels that. Now VAF is going to be equal to negative 16 divided by 4, that will be negative 4. That will be negative 4 meters per second. Okay, negative 4 meters per second, which is what? Which is VAF is equals to 4 meters per second. Now this should tell us about the direction. Okay, this is negative means to the left, that will be to the left. Okay, so that's how we use the conservation of what? The conservation of momentum to solve this problem. Now let us do example 2. Now with example 2, what do we have? We are still using the principle of conservation of linear momentum. A ball with mass of 50 kg runs at 7 meters per second eastwards and lands on a 20 kg cart that was moving at 20 meters per second eastwards. Calculate the velocity of the cart and the ball. Okay, so that will mean after the collision, this boy and this cart will move as what? As a unit. Okay, they will be moving as what? SA. So we are going to have a cart and the boy there. Okay, and the boy there. Obviously they will be moving in the same direction. So before we attempt to answer question, what do? We indicate the direction. So that will be what? That will be positive, that will be east, and this one will be negative, that will be west. Okay, now let us collect our data. For our data there, what do we have? We've got the mass of the boy, which is what? 50 kg, and then we also have the velocity of the buoy initial, which is equal to positive 7 meters per second. We also have the mass of the cart. The mass of the cart is 20 kg. The velocity of the cart initial is equal to positive 2 meters per second. Calculate the velocity of the cart and the buoy. So we're actually looking for what? We're actually looking for VF. So we come in and we see the sum of momentum initial is equal to the sum of what? The sum of momentum final. Okay. And then we see the mass of the buoy, velocity of the buoy initial plus mass of the cart, velocity of the cart initial is equal to, now since they've joined, you're gonna see the mass of the buoy plus the mass of the cart. They've got what? They've got a common VF. They've got a common final velocity. Now what is the mass of the buoy? The mass of the buoy is 50. The velocity of the buoy initial is 7 plus the cart. Mass of the cart is 20, and then the velocity of the cart initial is also positive 2, which is equal to, this is going to be 50 plus 20. We are looking for what? We are looking for the velocity of the cart and the buoy. Now doing the 2, that will be 50 times 7, that will be 350 plus 40 is equal to 20 plus 50 plus 20, that will be 70 VF. So this is going to be 390. 390 is equal to 70 VF, and then from here we divide both sides by 70, divide that by 70. This will cancel that, and then we're gonna have VF is being equal to 390 divided by what? By 70. That will be what? That will be 5,57 meters per second. Now because the answer is what? The answer is positive. The answer is positive, and we took positive to the east. That will be to the east or eastwards. Okay. Now we got the velocity of the buoy and the cart. Okay, good. Now let us move to the inelastic and elastic collisions. Okay, now elastic and inelastic collisions, because these two objects, what do? They collide. We have a situation where we've got a situation where we have what to call two objects that collide and separate, and we've got a situation where two objects collide and they join together and move as a unit. Now under elastic and inelastic collisions, we're going to have a situation where the total kinetic energy is conserved and the total kinetic energy is not conserved. Okay, so we're going to classify those type of collisions under elastic and inelastic. Now what is elastic collisions? A collision in which both total momentum and total kinetic energy are conserved. That one is elastic collision. So if two objects are very hard and no heat is produced in the collision, then not only momentum is conserved but kinetic energy as well. Okay, so the total kinetic energy before collision is equal to the total kinetic energy after the collision. Okay, so you say the sum of kinetic energy initial is equal to the sum of kinetic energy final. That is what? Elastic collisions. The formula for kinetic energy is what? It's half what you call, this will be this one. This will be for a situation like this one. Okay, when the two balls, what do? They, after collision, they separate. After collision, they separate. Okay, that will be the sum of kinetic energy before is equal to what? The sum of kinetic energy after. That is what? Elastic collisions. Now let us discuss now the inelastic collisions. Now for inelastic collision, a collision during which kinetic energy is not conserved. Okay, some of the kinetic energy is transformed into other forms of energy, such as what? Such as heat, light, or sound. Some energy get lost when objects deform during collisions. Okay, this is for what you call, for objects that can deform when they collide. Okay, so if two objects stick together as a result of collision, the collision is what? The collision is completely inelastic. Okay, so the total kinetic energy before the collision is not equal to the total kinetic energy after the collision. Okay, that will mean the sum of the kinetic energy before is greater than the sum of the kinetic energy after, simply because some of the energy is transformed into other forms of energy, such as heat, light, or sound. So we're gonna use the kinetic energies to prove whether the collision is elastic or inelastic. Now let us do the examples. Okay, now we've got what? We've got a 6 gram glass. Okay, this was supposed to be gram there. A 6 gram glass ball, which is ball A, moving east at 19 meters per second, collides with another 9 gram glass ball B moving at 11 meters per second in the same direction. After the collision, ball A moves west at 9.4 meters per second, and ball B continues moving east at 17.4 meters per second. Show that the collision is elastic. Okay, so how do we show that? We start by calculating the sum of EK initial. Okay, what will be that? That will be EK of what? Of A initial plus EK of B initial. Okay, that will be the sum of kinetic energy initial. But for us to make things easier for us, let us first collect what? Our data. For our data, what do we have? We've got the mass of A, velocity of A initial, velocity of A final, mass of B, velocity of B initial, velocity of B final. Okay, that will be A, that will be 6 divided by what? Divided by 1000, because we have to convert that to what? We have to convert it to kilogram. That will be 6 times 10 to the power 3 kg VA moving where? East. Okay, now we do what? We take that direction of east to be positive, that one to be negative. So east is going to be positive 19 meters per second, collides with a 9 gram, that will be 9 divided by 1000, that will be 9 times 10 to the power 3 kg. Times 10 to the power 3 kg, moving at 11 meters in the same direction, which is east, that will be 11 meters per second. Now VB, now after the collision, ball A moves west, ball A, that will be negative 9,4 meters per second, and ball B continues moving east at 17,4. Ball B continues moving east at 17,4 meters per second. Now let us do what? From here I think we've got enough information. Now let us come to substitute in our formula. That will be half MAVAI squared plus half MBVBI squared. Okay, because we're looking for the sum of kinetic energies before the collision initial. That will be half 6 times 10 to the power 3 squared plus sorry, my mistake. That is supposed to be we're supposed to have half. For A it's 6 times 10 to the power 3, a velocity initial, that is 19 squared, plus half the mass of B, 9 times 10 to the power 3, and then velocity B initial, that is 11 squared. So we punch this in our calculator. That will be half 6 times 10 to the power 3, and then we've got 19 squared plus half 9 times 10 to the power 3, and then we've got 11 squared. That will be 1,627,500. 1,627,500 joules. 500 joules. Okay, so we come to find the sum of what? Of EK final. That will be EK A final plus the kinetic energy of B final. This is half MAVAF squared plus half MBVBF squared. That will be equal to half 6 times 10 to the power 3. Final is negative 9,4 squared plus half mass of B, 9 times 10 to the power 3, and then the velocity is 17,4 squared. And then I punched all that in my calculator. That will be negative 9,4 half 9 times 10 to the power 3. That will be 17,4 squared. Yeah, that will be 1,627,500 joules. Okay, so it means what to call the kinetic energy, the total kinetic energy is conserved. So the sum of what? Of EK initial is equal to the sum of what? The sum of EK final. Therefore, the collision is elastic because the kinetic energy is conserved. It's conserved. Okay. Now let us now do example 2. Example 2. Okay. With the example 2, what do we have here? We have a 1,700 kg car moves at 25 meters per second west. It collides with a 3,400 kg truck traveling at 14 meters per second east. After the collision, the car travels at 10 meters per second east. Calculate the truck's velocity after the collision. So now we're supposed to find the velocity, the final velocity of the truck. Okay. So I take in that direction to be positive, that one to be negative. This one is east, that one is west. Now we have to collect our data. Now let us collect our data here. We have the mass of the car, which is 1,700 kg, and then we also have the velocity of the car initial, which is negative 25 meters per second, and then we have the velocity of the car final. After the collision, the car travels at 10 meters per second east, positive 10 meters per second, simply because we took east to be positive. The mass of the truck is 3,400 kg, and then what do we have there? The velocity of the truck initial, it is 14 meters per second. We are looking for what? The velocity of the truck final. So here we have to use the conservation of momentum. Okay, because about that one we are certain that the momentum is conserved. Okay, we cannot use the conservation of energy, of kinetic energy. We use the conservation of momentum. So that will be the sum of momentum initial is equal to the sum of momentum final. So that will be the mass of the car, velocity of the car initial, plus the mass of the truck, velocity of the truck final, is equal to the mass of the car, velocity of the car final, plus the mass of the truck, velocity of the truck final. Okay, so the mass of the car, we are told that is 1,700 negative 25 plus 3,400 times positive 14 is equal to 1,700 into final is positive 10 plus 3,400 velocity of the truck final. Okay, so when I say 17,000, 1,700 multiplied by negative 25, that is negative 42,500 plus 47,600 is equal to 17,000 plus 3,400, the velocity of the truck final. So make this one out. The answer is 5,100, and then we transpose this one. When we make this one, we get this. We transpose this to this side. That will be negative 17 tau is equal to 3,400 velocity of the truck final. Negative 11,900 velocity of the truck final. We are looking for the velocity of the truck final. So what do we do from here? We divide both sides by 3,400. 3,400. This cancels that. Now the velocity of the truck final is going to be equal to negative 3.5 meters per second. The velocity of the truck final is going to be 3.5 meters per second, where the direction will be, because it's negative here, west, westward. That will be the direction. So B, this was A. So for B, this is show that this collision is inelastic. Okay, now how do we show that? Now that we have what we have here, we know that this is negative. We just found it there. This is negative 3.5 meters per second. We got this one there. Now we have everything. Okay, so now for B, let us do B. For B, we're gonna say the sum of EK initial is equal to EK A initial car, which is the car initial, plus EK truck initial. That will be half M car, velocity of the car initial squared, plus half M truck, velocity of the truck initial squared. That will be 1/2. The mass of the car is 1,700. It's 1,700, and the velocity initial is negative 25 squared plus half. The velocity of the truck is the mass 3,400. The initial velocity of the truck is 14, and then we say 14 squared. So we try to get that 1/2 times 100 whole squared 1/2 14 squared. So we get 864,450 joules. Okay, and then we come to find the sum of EK final, which is EKA final plus EK car final and EK truck final. That will be half M car V car final squared plus half M truck V truck final squared. That is going to be 1 over 2 1700. We were given the velocity of the car final as what is squared plus half, and then we got this as what, negative 3,5 squared. And then we come to our calculator, we punch all that. Half 3,400 times negative 2.5, that is 105,825 joules. Okay, so from here we can see that here we had 864, now we have 105,825 joules. Okay, where did some of the energy go? So this sum of the energy was converted into other forms of energy such as sound, heat and light, and it was also used for the deformation of the car and the truck. So here we're gonna say, okay, the sum of EK initial is what? Is greater than the sum of the EK final. Therefore, the collision is inelastic. Okay, so that will be the end of my lesson. I hope you enjoyed this lesson. Let us meet again on our next lesson. Thank you.